question number 81, which says that which of the following molecule has the non-zero dipole moment. So if I talk about para-dichlorobenzene, the dipole moment exactly cancels out each other. So in this case, mu is equal to 0. This is not our answer. Now we have trans-2-butene. So we can draw the structure like this. So in this case also the dipole moment cancels out each other. So we have mu equal to 0. So now if I talk about boron trichloride, which has a trigonal planar shape. So this is the resultant dipole moment of these two vectors. So means these two cancels out each other. So here also mu is equal to 0. But now if I talk about this compound, ऐसे compound को देखने में लगता है कि dipole moment cancels out each other. But the actual scenario is like this. We have two lone pairs present on the oxygen atom. So due to the presence of two lone pairs on the oxygen atom, here the dipole moment does not cancel out each other. So mu is non-zero. So option number 1 is the correct answer. So next we have question number 82. The maximum number of spectral lines formed when electrons in fourth excited state return to ground state. So fourth excited state का मतलब क्या हुआ? Means n equal to 5. So now it is returning to ground state, means n equal to 1. So now we have to calculate the number of spectral lines. So whenever the electrons are returning to ground state, we have the formula to calculate the spectral line, that is n minus 1 by 2. And here n is equal to 5. So you will get here 10 spectral lines. So option number 2 is the correct answer. So moving on to the next one, we have question number 83, which says that the ratio of the frequency of revolution of electron in the first excited state of helium plus and the third excited state of hydrogen is. So the frequency of revolution is directly proportional to z square divided by nq. So now we have to calculate the ratio for helium plus and for hydrogen. So for helium plus, z is equal to 2. So it will be equal to 2 square divided by nq. So in the case for helium plus, we have been asked for the first excited state. So for the first excited state, n is equal to 2. So here it will be equal to 2 cube. So now the z for hydrogen is equal to 1. And for the hydrogen, we have been asked for the third excited state. Means n equal to 4. So here it will be 4 cube. So it will be equal to 32 divided by 1. So the ratio will be equal to 32 is to 1. So option number 3 is our correct answer. So moving on to the next one, we have question number 84, which says that the wavelength of limiting line of Lyman series in helium plus ion would be. In limiting line of Lyman series, n1 will be equal to 1 and n2 will be equal to infinity. So now apply the Rydberg formula here. So the mu bar, which is wave number, is equal to 1 by lambda, so which is equal to rz square 1 by n1 square minus 1 by n2 square. So the R value we have been given, that is 109677, and the Z value of helium plus will be equal to 2. So here it will be equal to 2 to the power 2, and N1 we have 1 and N2 we have infinity. So here will be equal to 109677 into 4. So if I calculate the lambda, so it will be equal to 2.279 into 10 raised to the power minus 6 centimeter. So you convert this into angstrom, it will be 227.9 angstrom. So option number 2 is the correct answer. So moving on to the next one now, we have question number 85, which says that a compound is made up of two elements A and B, in which A constitutes 70% by mass. The atomic weight of A and B are 56 and 16 respectively. The formula of the compound is, so we have elements A and B. So the percentage composition is 70 and 30. So we can calculate the number of moles. So the 70 by 56, 56 is the atomic weight of A. So it is equal to 1.25, and here also 30 divided by 16. So it is equal to 1.875. So divide this by the smallest number. So it is equal to 1 and it is equal to 1.5, and 1.5 we can write it like this, 3 by 2. So A we have 1 and B we have 3 by 2. So this simple formula of the compound will be A2B3. So option number 4 is the correct answer. So moving on to the next one,